Hi, this is the Science Chef. In this video, I will teach you how to determine your titer value for the 2023 WAEC Chemistry Practicals. Please note that this video is for teachers only, so if you're not a teacher, please skip, don't watch. As a student, if you like to watch our other WAEC 2 2023 preparation videos, you can check the link in the description. Alright, let's start. The 2023 WAEC Chemistry Practical is an acid-base titration. That's the volumetric analysis aspect of that practical. It's an acid-base titration between hydrochloric acid and sodium trioxocarbonate 4, that's Na2CO3. Based on instruction given, the volume of the stock HCl to be used is 8.5 cm3, and the mass of the sodium trioxocarbonate 4 decahydrate to be used is 5 grams. In other words, you are making use of hydrated salt in the analysis. So you should be expecting a question on water of crystallization. In our subsequent videos, we will do tutorials on how to calculate water of crystallization. Then, for you to determine the concentration of the HCl that will be used in that titration, you need to know the specific gravity of the stock HCl you are using. In other words, the concentration in grams per cm3 of the stock HCl you are using, which is always written on the bottle as something like the write as SG. So you check the bottle containing your stock HCl, you'll see SG, the value written there. Most times it's always between 1.18 grams per cm3 to 1.20 grams per cm3. So depending on the specific gravity of the HCl you are using, that's what you should be using in this calculation, right? Then the assay of the stock HCl is also written on the body of the bottle. On that label, you'll see the assay, right? The one commonly used is 37%, right? It ranges between 36 to 37%. So depending on what you are using, if you are using 36% stock HCl, then you should be using 36% in this calculation, right? If you are using 37% stock HCl assay, they should be using 37% in this calculation, right? Then we will need to calculate the molar mass of the hydrated sodium trioxocarbonate 4, which is 286 grams per mole as seen here. Let's now dive into how you're going to calculate your concentration of HCl, because from the concentration of HCl, you can easily calculate the concentration of the base, right? Since you have the mass and the molar mass, you know the mass, concentration, and the molar mass, right? And from there, you can get the concentration of the base in moles per dm3. Then, of course, using your volumetric analysis formula, your CAB over CBB is equals to NA over NB, you can then determine what the volume of acid to be used will be, right? Alright, let's go. Now, based on the information provided in the instruction, to calculate the mass of the HCl present in the volume of the stock acid, we are going to use volume times specific gravity times the assay. Note that the assay here is the word purity of the acid, and since you are dealing with 37% purity, it means that out of every 10 mils of the stock acid solution, 3.7 mils contains what? Pure HCl. So from here we're going to substitute the values as 8.5 cm3 times this specific gravity gives us the mass of the acid present in 1 mil or 1 cm3 of the solution. So it's 1.18 grams present in what? In 1 cm3. So times 37 over 100, right? So this will cancel out this, and if we evaluate, this gives us 3.711 grams. So which means that the mass of the HCl we'll be working with is 3.711 grams. So since you are asked to dissolve 8.5 cm3 of the stock acid in 1 dm3 of water, remember you add acid to water, not water to acid. That's the precaution you must take while preparing your acid solution, right, for the examination. Since you are asked to add 8.5 cm3 of the stock acid solution to 1 dm3 of water, it means that that 1 dm3 of solution will contain 3.711 grams of the acid, right? So which therefore gives us the concentration in grams per dm3 of the HCl as 3.711 grams per dm3. So the concentration in moles per dm3 of the acid is given as well concentration in grams per dm3 divided by the molar mass. And since we have calculated the concentration in grams per dm cube to be 3.711 grams per dm cube, so we're going to divide this by the molar mass of HCl, which is 36.5 grams per mole. If we evaluate this, that will give us about 0.101 mole per dm cube. So remember, this value depends on the assay and specific gravity of the stock acid you're using, right? Approximately to be 0.100 mole per dm cube, right? So let's approximately 0.100 mole per dm cube. Some of you may get 0.09 something mole per dm cube, which is approximately 0.100 mole per dm cube. Good. So given this now, the next thing we are going to do is to calculate the concentration in moles per dm cube of the hydrated salt, which is concentration in grams per dm cube over its molar mass. Its concentration in grams per dm cube as given in the instruction is 5 grams in 1 dm cube, right? And the molar mass that we've calculated is 286 grams per mole. So if we evaluate this, we'll get about 0.0175 mole per dm cube. Good. So now that we have the concentration of our acid as 0.100 mole per dm cube and the concentration of our base as 0.0175 mole per dm cube, right? It's very likely that the acid would be in the burette, so the volume of acid, which we do not know, and the base would be measured with the what pipette, so the volume of the base would be what 25 cm cube, right? And since we'll be using the base to standardize the acid, we can then use our formula, and if we make V a subject of formula, this will be CbVb times 2 all over Ca times 1. So if you substitute the values, that will be 0.0175 times 25 times 2 all over 0.100, and evaluating this will give us about 8.75 cm cube. So this gives us the theoretical titer value that you are expected to get in this practical examination. But remember, I said this is a theoretical value, so due to some human errors, right, and interferences, there's a tendency that you will not get this exact value, but this will serve as a guide to you to know that you are doing the right thing, right? So it means that practically you are expected to get a value between 7.50 to 10.50 cm cube as your titer value. Get anything within this range, then you are good to go. Although even if you get beyond this range, provided you do the correct thing, there's no problem. Whatever you get, record it. But this is just to serve as a guide on what to expect, right, while you carry out your practice. So that brings us to the end of this tutorial. If you learned anything from it, give us a like, subscribe to this channel if this is your first time here, and don't forget to turn on your notification bell, because our next video will be on the likely questions that can be asked on the 2023 WAEC Chemistry Practicals. So ensure you stay up to date by turning on your notification bell, right? Remember, if you have integrity, nothing else matters. And if you lack integrity, nothing else matters. So remain true to yourself until I see you, and I'll see you